For the final example problem that deals explicitly with vectors, we are asked to add two vectors a and b and then find the magnitude and angle of the vector that results. So we are given that vector a has a magnitude of 5 and lies 27 degrees below the negative x-axis. Vector b has a horizontal component of 3 and vertical component of 4. So let's draw those vectors out and see what they look like. So here are my x and my y axes as usual. I'm going to draw vector b first because vector b already is explicitly given in component form. Vector b has a horizontal component 3 and a vertical component 4. So I could say 1, 2, 3 to the right, positive 3, 1, 2, 3, 4 upward, positive 4. Vector b is going to look something like this. So I could say bx is equal to 3 and the vertical by is equal to 4. So vector b, all right, is given to us in component form. Next, I want to find the components of vector a. Now, vector a is given to us as a magnitude of 5, so we know how long we want to draw our arrow on the board. I want to emphasize that the length of a vector is a mental picture. Vectors don't always necessarily have length. Vectors are not necessarily always measured in meters. They can be measured in meters per second or meters per second square. But if you're representing a vector with an arrow on a piece of paper or on the board, often a larger vector will be represented by physically drawing a longer arrow on whatever you're writing on. So sometimes I will say the length of an arrow, the length of a vector, but strictly speaking, length only really applies when we're talking about a vector like displacement. So the vector is pointing below the negative x-axis. So let's think about what that means. The direction of positive x is to the right, and I think of this as the positive x-axis. If the positive x is to the right, that would imply negative x is to the left. So vector a is not pointing along the negative x-axis. Vector a is pointing below the negative x-axis. So vector a is going to be pointing something like this, downward, an angle 27 degrees below the negative x-axis. So vector a will look something like this. So here's vector a. It has a magnitude of 5, and vector a is going to be 27 degrees below the negative x-axis. Now, how do we find the components of vector a? We could use either of the methods we discussed in previous videos. I'm going to choose to use the method where I begin pointing along the positive x-axis, I begin pointing to the right, and then I will sweep around in a counterclockwise direction until I'm aligned with my vector. And once I do that, I just ask how much of an angle did I rotate through, and that's the angle I use. So I could say AX is equal to 5 cosine of an angle. AY is equal to 5 sine of an angle. What angle do I want to write in here? Well, from here to here will be 90 degrees. From here to here will be 180 degrees. So we need to rotate 180 degrees plus 27 degrees more. 180 plus 27 is 207. So we will rotate by an amount 207 degrees. Now when you perform this calculation in a calculator, I said degrees, so make sure your calculator is in degree mode. And I put that number in a calculator, and for AX, I get negative 4.46. For AY, I get negative 2.27. 2.27. So at this point, I found the components of vector A and vector B. all four components between the two vectors. So I'm going to write them over there so I have easy access to them. So AX is negative 4.46. AY, we said, is negative 2.27. BX is 3. BY is 4. Great. Now, as I said before, we are trying to find a new vector called, I'm going to call it vector C. I like to label it the new vector when I find it. So C is equal to A plus B. Vector C itself will have components to it. I could say Cx is equal to Ax plus Bx. So using the values I have over there, Cx is equal to negative 4.46 plus 3. So Cx is equal to negative 1.46. And very similarly, Cy is equal to Ay plus By. So Cy is equal to negative 2.27 plus 4. So Cy is equal to negative 2.27 plus 4, 1.73. So here are my horizontal and my vertical components for vector C. So we found information about vector C, but the problem is explicitly asking for what is the magnitude of vector C, what angle is vector C at in relation to the positive x-axis. So to answer those questions, I am now going to draw out vector C in an xy coordinate. So if I were to draw that, I would have something like this. Here is my y-axis. Here is my x-axis. And I drew this with a lot of space in the second quadrant because looking at the numbers I found, I have a negative number for my x component and a positive number for my y component. So I know I'm going to move negative 1.46 to the left and positive 1.73 upward. So negative 1.46, positive 1.73, vector C will look something like this. So this is vector C, where Cx is negative 1.46, Cy is positive 1.73. So here is Cy, here is Cx. Now, looking at how I drew this picture, I notice there is a right triangle. So the two questions, what is the magnitude of this vector? What angle does the vector make in relation to the positive x-axis? To find the magnitude of this vector, I'm going to look at this and I'm going to notice that this triangle looks very similar to a different triangle. It technically isn't the same thing, so I'm going to draw it in a different color. But this triangle looks very similar to a triangle that is 1.73 units this way, 1.46 units this way, and I'm going to call this just C. So if I had a triangle like this, and I asked you to find C, you could just use the Pythagorean theorem to find it. You could say 1.46 squared plus 1.73 squared equals C squared. And then you would put numbers in a calculator And don't forget to take the square root when you are going through your calculation, and you find this number c is equal to 2.26. Now, what is the justification? The only difference here is I wrote this number explicitly as positive, but this number here was negative. Well, that is true, but think about to chapter 2. If your displacement can be negative or positive, but the distance you walk is always going to be a positive quantity. I am really only caring about the absolute value. What is this distance? What is this distance? And if I know this distance and this distance, I could find the magnitude of this vector. So for what I'm doing here, I can find c by using the Pythagorean theorem, pretending these values are inherently positive. Even if I were to plug in negative 1.46, it would still end up just being destroyed. The negative would end up falling away when I square it anyway. So I could say the magnitude of vector c is 2.26. Magnitude of vector c is 2.26. Great, we found one of the two things that the question is asking us to find. The other thing that the question is asking us to find is what angle does the vector make in relation to the positive x-axis? I want to explicitly mention here that when a question is worded like this, they mean assume you are initially aligned with the positive x-axis. So if I'm initially aligned with the positive x-axis, what angle do I need to sweep around until I reach my vector? So I know this is a 90-degree angle from the positive x-axis to the positive y-axis. I know it is a 180-degree angle from the positive x-axis to the negative x-axis. So whatever angle it is, this angle I'm trying to find here, this angle theta is going to be something between 90 and 180 degrees. So how do we actually find theta? There are a few ways we could approach this question. One way we could think about it is, let's look at a different angle. Let's look at this angle right here. This angle here, I'm going to call this angle phi. It's a different angle given by Greek letter phi. Now, I do not know what phi is. I do not know what theta is, but I could look at this picture and say, if this from the positive x-axis to the negative x-axis is 180 degrees, and I notice I travel theta degrees, then I travel phi degrees, I got to the negative x-axis, I could say that theta plus phi must be equal to 180 degrees. So if I could find phi, that is practically as good as finding theta. Then it's a very short step to just find theta and you're done. So I could again use this triangle that I used here, and I notice this triangle lines up very nicely with this triangle over here. So I could just write in phi over here. So how would I find what this angle phi is? I would have to use some inverse trig function. So this is 2.26. Which inverse trig function do I want to use? At this point, it really doesn't matter. You could use anything. We have all the lengths of all three sides of this triangle, so just use whichever one. I could say the sine of phi is equal to 1.73 over 2.26. Now I will take sine inverse of the left and right side. So I could say sine inverse of sine phi is equal to sine inverse of 1.73 over 2.26. We said before that if you have sine inverse and sine, they will cancel each other out. And all that's left here is your angle phi. And on the right-hand side of this equation, I take 1.73, I divide by 2.26, I hit enter on my calculator, I get some number. And then I could take the sine inverse or the arc sine of whatever that number is, and I hit enter on my calculator, and I get phi is equal to 49.8 degrees. Now, I did not find the angle that we are looking for. The book asked us to find theta, but I am practically done with this problem, because at this point, I could just say theta plus 49.8 is equal to 180. So I could subtract, and I find theta is equal to, in this case, going to be 130.2 degrees.